Thursday night was to do the solve by graphing, right? You had 1 through 7. I think a lot of you did a lot of it in class, but then we finished it for homework. Do you have any questions on that? 2? Somebody said 2? Okay. Number 2. F of x equals negative x squared minus 10x minus 25. So remember, whenever I'm graphing to find the solutions, I'm looking for the what? Close. What are the solutions of a quadratic graph? The x-intercept. So I'm looking for the places where it crosses the x-axis, right? All right, so knowing what I know about quadratics, I know that this one's going to open down. It's going to be an average width, and the y-intercept is going to be all the way down at 25, so that might not be a very easy point for me to use. All right, so first thing I'm going to do is find the vertex. X opposite b, so b is negative 10, so I'll use positive 10 there, over 2a, which is negative 5. Everybody good there? Yes, no, maybe so. And so then if I plug negative 5 into my equation for x, I find that y is negative. And a lot of you were messing up on this last week. When you plug a negative in here this way, when the sign in the front is negative to start with, that negative in front of the x squared causes it to always be negative no matter what you plug in there. So the squared's going to make the negative 5 positive, but then that negative in front's going to take over. So this is going to be negative 25. Then I've got a negative and a negative, plus 50 minus 25, which is going to be 0. So that vertex is negative 5, 0. And so several of you, when we talked about this last week, you actually did use that as your other easy point, and you took your graph and you went by 5s for every tick mark. And that's fine too. You can definitely do that. And if you did that, this would be my vertex, right? And then if I go down to negative 25, I could use that as my easy point and then reflect and connect. But that was not all you had to do, because you also had to do what? Factor and solve, right? Are y'all with me? Yes, thank you. So what I'm going to do is take the negative out of the front first, because I never want to factor with a negative in front. So I am going to have negative 1 times x squared, change all those signs, and now I can factor. What do you notice about that quadratic? It looks like a what? Looks like something special. A perfect square trinomial. That's exactly right. Good job. So perfect square trinomial, both the ends are perfect squares. If I do the square root of the ends, put them together and double, I get what's in the middle. So to factor it, I can just do the square root of the first sign, the square root of the last. And if I set that equal to 0 so that I solve it, then I get x plus 5 equals 0. Subtract 5. Is that where my x-intercept is on my graph? It absolutely is, so that's my check there. Y'all good? That was a one solution scenario where the vertex sits on the axis. Are y'all sleepy? Y'all look like miserable. All right, anything else from your homework? 4? Flip it over to number 4. Another with a negative in the front. I take it y'all don't like the negatives in front. Y, I'm going to just change that to y equals negative x squared minus 11x minus 28. So when I graph this, ooh, what a nasty vertex here. Let's do the opposite b over 2a. Opposite b over 2a. 11 over 2, which would be 5.5. I'm probably going to use that stove function on my calculator here because to plug this in, it's going to be pretty, I don't have my calculator up here with me. Did anybody get that? Tell me what it equals. What'd y'all get for the y part there? What'd you get? 96? 9/4. Is that what everybody else got? Anybody, or did y'all not get it? No, I didn't get that. You didn't get that. Thank you. Y'all remember how to do the stove? Anybody else? All right. If you don't remember how to do this, or you didn't have a calculator when we did it, let me just show you one more time, because it is quite handy. It'll help you with those negative signs too. If I do 5.5, then I hit this button down below the LN that says STO, and then the X button right below mode. That tells my calculator that every time I type X, remember that it's 5.5. So hit enter, and now all you have to do is type your equation. So the equation was negative x squared minus 11x minus 28. Ooh. What if I wanted to make that a fraction? Math. So negative 118 and 3/4. Negative 118. We'll keep it as a decimal. Y'all like that a little better. I'm probably going to go by tens on my graph. Is that what y'all did? Is there room to go by 10? I'm just going to have to go down a little further on that paper if I use that one. But I'm going to go, if this is 10, so I'm about in the middle, and it doesn't have to be exact here. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, somewhere around here is my vertex. Now I'm going to go in. Maybe it wouldn't be a bad thing then to use my easy point, my y-intercept of 28. 10, 20, about 28 right here. Flip it over. And I have to remember here that I'm going by tens as I look to check my answer, right? So let's factor it and see what happens. Take the negative out before you factor. What multiplies to 28x squared but adds to 11x? 7 and 4. 7x and 4x. And so now keep that negative with it as you go down. X squared plus 7x plus 4x plus 8. GCF here. X. What's left? X and 7. X plus 7. Middle sign's plus. What's the GCF here? 4. What's left? Hopefully the same thing, right? Hopefully my parentheses match because that's what I want them to do. What? Oh, no, thank you. Which means these are both going to be negative. Thank you, guys. I'm so sorry. So this was minus, so negative, so 2 negative. Oh, no, that doesn't work anymore, does it? Is it not factorable? What multiplies to negative 28 but adds to positive 11? Oh, no, I factored the negative out in the beginning, y'all. If you factor that negative out, it changes all the other signs. So that was right. We were right. Y'all see what I'm saying? Are y'all with me or no? Did I just really mess everybody up? So if you start with a negative in front, you want to take that out. When you take that out, remember you have to take it out of everything. So when I took it out of everything, it changed every sign that followed. So it made this sign positive and this sign positive. That's why it's a positive. But you are right, in the beginning it was positive. I mean, it was negative 28. So now I have x plus 7. It doesn't match my graph. Oh, wait. Where'd I mess up, y'all? Y'all like, I don't know. My graph should be opening down and it's not. Where did we mess up? Say that one more time. You're absolutely right. Which would make that negative 5.5. So now if I plug in negative 5.5, I store that as x and then I re-enter that equation. Guess what we get, Christina? Y'all should have hollered at me instead of letting me do this whole problem wrong. I'm a little bit embarrassed. So it is 2.25. You were right. I'm sorry. I can't believe nobody told me I didn't do opposite B. I know. But I still make mistakes. All right. So we are back to, but as a teaching moment here, good thing I was factoring and solving, because at the point that I factored and I saw that it wasn't crossing there, I knew I'd done something wrong, right? Something went awry somewhere. So here, negative 5.5 and 2.25, there's my vertex. Much, much better. 1, 2, 3, 4, 5, and then up to 1, 2 and a quarter. Yes. Now I might plug in my easy point. I might let x, I thought that one was awful hard to be on this sheet. I'm going to plug in negative 5 for x instead of using this 28, this negative 28, because that's way far away. I'm just going to go over a half and use negative 5. And again, I'm going to use that store function on my calculator. And I'm going to let negative 5 store that as x. And let me show you what I'm doing here. Now I changed it to negative 5 to store it as x. Instead of even retyping that, if you hit second enter, it'll pull up the last thing you typed. So hit second enter again, and it'll pull up that equation. You don't have to do that. It's just a little time-saving trick we talk about for standardized tests and stuff. And I get 2 when I plug in negative 5. I apologize, guys. I really flubbed that problem up. So y would be 2 here, when x is -5. So I go up to, it was up to 2 1/4. So it's going to be down ever so slightly. I'm going to reflect and connect. Now I open down, and now I do look like I'm crossing closer to, if my graph was a little more accurate, a little closer to 4. That's supposed to be -7. Again, if I was on graph paper, it'd be a little closer. But it does look like my graph supports my answer there. A little bit better, a little bit better. All right. Y'all good? Did y'all get number 6? Y'all okay on number 6? Number 7? Sure. Another negative in the beginning. Y'all don't let me do it wrong this time. Y'all keep watching me. Negative x squared. We'll take a little break after we finish going over the homework because it's kind of. All right. It should open down. It should cross the y-axis at -17. Let's see what happens. Opposite b over 2a, which is +4. Do we agree? Now if I plug that in, I'm going to show it here, but on my calculator, I'm going to store 4 as x. And I'm just going to type -x squared plus 8x minus 17. And I get -1. So 4, -1, 1, 2, 3, 4, -1. Probably not going to use that y-intercept because it's pretty far away and it's down low. What's a good easy point to try? What about easier than that? If I'm at 4, what's pretty easy to use? 3. I would use 3 or 5 because it's 1 away from the vertex. You want to stick close to the vertex so you don't get really big or really small. If I plug that in, and again, I'm going to use store on my calculator. I'm going to show how it would plug in, but as far as doing that math, so again, I'm going to 3 store x. I'm going to pull up that last equation, and I get -2. 1, 2, 3, 1, 2. I'm going to reflect it, connect it. Ooh. What does this look like? It looks like no solutions, doesn't it? It's never crossing. So my factoring should support that. And in fact, if I take a negative out, I'm left with x squared minus 8x plus 17. What multiplies to 17 but adds to -8? Nothing, right? This cannot be factored. We're going to see in the next couple of days that doesn't necessarily mean there's no solutions, but it definitely sometimes means that there's no solutions. So it does support it graphically. Everybody okay? All right, y'all take a couple minutes if you need to get some water, if you need to go to the bathroom. You need to stand up and stretch for just. All right, let's talk about square roots first. We've talked a little bit about square roots. We've talked about perfect squares as we looked at perfect square trinomials. So tell me, and I'm not really following these that are up here if you like the little guided notes. We can go in and fill in those blanks after I finish the notes. You should know what those are at that point. But tell me, what is a perfect square? What does it mean to be a perfect square? A number times itself. That's exactly right. A number times itself. And I told you to be able to recognize those perfect squares up through, I think, 13 at least. So let's start. We start with 1 times 1 is 1. And then 2 times 2 is 3 times 3 is 9. 4 times 4 is 16. Keep going. 25. 64. At least be able to recognize up through those. Now, For what we're doing today, when we simplify these radicals, it may be helpful as you get started to have these. Do y'all remember learning simplifying radicals in Algebra 1, where you split them up? No, okay, thank you very much. I appreciate that. No, we don't remember. So it may be helpful for you to have a list of these on the side of your paper as we go through, because that's what we'll be referencing each time. Now, I've titled this square roots, and I'm talking about perfect squares. So I guess my first question is, these are perfect squares, but what does it mean? What is a square root? What does that mean? Or what's it look like, first of all? It does. It kind of looks like a division thing, kind of like a check mark division thing. What is that sign called? Yeah, half of a bracket. This is more like this. Y'all don't know what that's called? It's called a radical. That's exactly right. It's called a radical. This is, in fact, a square root. And I can imagine, and this will be a little helpful as we get a little bit further, I can imagine this little imaginary 2 that sits right outside, very little, almost like it's sitting in a seat on that radical right there. And you know how we have the imaginary 1 in front of any variable that's being multiplied? This is an imaginary 2 that sits there that tells me, hey, I'm looking for anything that multiplies by itself 2 times to give me what's under here. Okay, so what times itself twice gives me what's under that radical. Now, everything does not have a square root or a perfect square root, right? Because what if there is not a number? What if I asked you, what number times itself 2 times gives you 10? There's not one, right? There's not a whole number. That would be a decimal. So that's not a perfect square. But any of these numbers in this list, in fact, I could put a square root over them and they would have a perfect square. In other words, what number times itself twice gives you 4? 2. What number times itself 2 times gives you 121? See what we're doing here? Now I'm going to throw one more little wrench in our plans here, because when you take a square root, you told me 2 here, but what if I told you it could also be -2? Would you agree? What's -2 times -2? 4. It's still positive. So because of this, when we take a square root like this, we always put our answers with a plus or a minus in front, okay, to tell us that it could be positive or it could be negative. Everybody okay so far? So this is actually this. So if I said, what is the square root of 36, what would you tell me? Or -6. I would say plus or -6. You do both, okay? So anytime you're asked for a square root, we're always going to include plus or minus in our answers for radicals, okay? Now, let's also rewind back to Algebra 1, and let's talk about the properties of these radicals, because they have some little bit special properties. Y'all have that? Why I'm so sluggish on today. All right. The first one is a multiplication property. And it says that if I'm multiplying 2 things together under a radical, I can split them up. Still multiplying, but I can split that radical into 2. So for example, if I had the square root of 4 times 10, I could split that up in the square root of 4 times the square root of 10. And that's handy because the square root of 4 is what? 2. So this would just become 2 times the square root of 10. I haven't graded your quiz yet.
I got to fix something like this.
No, you can't fix it now.
I didn't realize what I did wrong. I swear, nah. I swear. On the one you had to plug in.
When you do your plus or minus here, always throw it in front of the radical expression here. Don't put it after the 2 because that would imply that I'm not multiplying anymore. It would imply, bless you, that I'm adding or subtracting. So that's always something. Do y'all remember doing this? No. Okay. That's okay. That'll be okay. Getting the distinct feeling we're only going to make it through the one page and not the second one, but we'll see. All right. Bless you. So that's property number 1. The second, now if you want to write this on the sheet, that's fine too. It doesn't matter to me. However, whatever's easiest for you to keep up with to go back and look as you get ready for your tests and stuff. The second property, and I really just want to talk about these 2 properties and that'll be it, is very similar. It's multiplication. The first one's multiplication, the second one is division. So just like with multiplication where I can split them up, with division I can also split them up. Now notice I do not have a plus or a minus property here because you cannot, and you need to make a note somewhere, you cannot split addition or subtraction. It does not work, and there will be somebody that tries to do that. If you have the square root of 2 plus 7, you cannot make that the square root of 2 plus the square root of 7. You just can't do it. Never, never, never. Same thing with subtraction. You cannot split up subtraction. But you can split up multiplication and division. Now, the easy part is splitting this up, but the hard part comes because, and I hope y'all remember this at least, you can never leave a radical in the denominator. Have y'all heard that rule before? You can't leave a radical in the denominator. It's bad math, and we don't do that. So we have to do what we call rationalize the denominator. What that means, if I have the square root of 2/3, that is the same thing as the square root of 2 over the square root of 3. Do you agree? Okay. I can't have that square root of 3 down there. So do you remember what you have to do? Does anybody remember how to rationalize that? To get it out, I multiply the top and bottom by the bottom radical. I should really say numerator, denominator, and so on, but I'm being lazy and it is a lot quicker to write bottom than numerator and denominator. So what that means is, take the radical that's in the bottom right now, which is what? Square root of 3, right? Multiply the top and the bottom of that fraction by that square root of 3. Now, I can do this because what is the square root of 3 divided by the square root of 3? 1, right? Anything divided by itself is 1. What happens when you multiply something by 1? It equals itself. It stays the same. I'm not changing the value here, right? Now, what is the square root of 2? When I multiply fractions, I'm top times top and bottom times bottom. What is the square root of 2 times the square root of 3? The square root of 6. We just learned that property, right? What's the square root of 3 times the square root of 3? What is it? Square root of 9, right? Multiply them. And what is the square root of 9? So in fact, any radical that you multiply by itself, the square root of 2 times the square root of 2 is 2. The square root of 5 times the square root of 5 is, what do you think it is? The square root of 3 times square root of 3 is 3. The square root of 2 times square root of 2 is 2. What's the square root of 5 times square root of 5? Which is, right? What's the square root of 25? What's the square root of 7 times the square root of 7? Which is, see what's happening there? They cancel out and leave you with what's under there. Yes, so we're going to put the plus or minus in front. You cannot divide those because the top's under a radical and the bottom's not. So you leave it and it's done. We're still in what you should know from Algebra 1. We haven't jumped out of that yet. Everybody's still okay. Have you at least seen this before and just don't remember it? Okay. We'll make sure y'all have at least been introduced to some math here. One more Algebra 1 concept that is the hardest that I spend the longest on before we get into the Algebra 2 stuff. I know, I'm sorry. I heard no G's. Simplifying radicals. This is what the whole first page that I gave you is on. Simplifying radicals is when we split the radical by any perfect square factors. What does it mean to be a factor? What's a factor? It multiplies to give you the number, or give it to me another way. What else? Divides evenly without a remainder, right? What are the factors of 6? 2 and 3, right? 1 can always go in 1, 2, and 3 are the factors of 6. What are the factors of 12? 1, 2, 3, 4, and 6, right? You see where we're going? See how we're doing this? It goes in evenly. All right, so I'm going to split the radical by any perfect square factors. So, for example, let's say I have the square root of 18. Is that a perfect square? Can I take the square root? Because I want to try that first. No, that's not a perfect square. So always check first. That's not check, that's check. Put PS for a perfect square. If it's not a perfect square, the next thing I want to do is I want to look to see, can I divide by a perfect square? And I'm going to put a little note here. Choose, choose the biggest possible. So for 18, remember I told you to have that list over on the side? We had 1, 2 squared is 4, 9, 16, 25, 36, 48, 9, 10, 11, 12, 13. Can I divide what is the biggest number from that list I could divide 18 by? 9. Do we all agree? 9 times what? 2. When I find that number, I'm going to write as a multiplication problem. Multiplication problem. And split it up. So this becomes the square root of 9 times 2, because 9 is the biggest number on this list that'll go into 18. Multiplication problem, sorry. That's not any better. I'm sorry. Multiplication problem. Now let's split them. Oh, multiplication problem. I'm sorry. Uh-huh. So I have the square root of 9 and the square root of 2. What's the square root of 9? The plus or minus goes in the very front. Now it's simplified. And I know it's simplified because what's left under the radical cannot be split any further. Does that make sense? Yes, no, maybe so. All right, let's do several examples together. Oh, still in the algebra 1 stuff, man. If there's a number in front, remember that is multiply. So this is 4 times. That's not the itty bitty 2 like I was talking about earlier. That's 4 times the square root of 72. So look what's under the radical. And I divide this by any perfect square. Look at that list you have. What's the biggest one on that list? You don't want to do the smallest, you want to do the biggest one. What's the biggest one from that list? I could divide it by 36. 36 and what gives you 72? 2. So I'm going to split this up. I've got the 4 that's staying on the outside, and I'm going to write this as 36 times 2. Split the radical. If you don't need to include this middle step, you don't have to. You can jump straight into splitting them up if you see that. What is the square root of 36? 6. So I have 4 times 6 times the square root of 2. And what's 4 times 6? I'm missing one little thing. There you go. Easy, hard, don't know yet. Okay. Start out easy here. What should I do? Split them. Now what? And before I do that, what do you notice? 9's a perfect square. What's the square root of 9? I could just leave it like that. But if this changed to this, how's it different? Now it's not a perfect square, right? It's square root of 2 over square root of 3. And now, Aaliyah, you're absolutely right. I'm going to multiply it by square root of 3 times bottom, right? What's square root of 2 times square root of 3? What's square root of 3 times square root of 3? Can I simplify that 6 and 9? I hear yes and I hear no. But the 9's not under a radical. I was kind of tricking you, and I'm sorry. Don't simplify those unless they're both under the radical. So you leave it just like that. Say again. Because the square root of 3. Oh, that's 3, y'all. I'm sorry. Thank you. That's what you're fixing to tell me? Yes, it would be under a radical. It'd be square root of 9, which is 3. My brain is not here today. I'm sorry, y'all. Busy weekend, lots. All right, I got one more thing to show you and I'm done. I know I've been talking a long time. I don't like to talk this long. But I felt the need to go back and review all that Algebra 1 stuff because I didn't think you'd remember. Was I right? Okay. So now let's talk about the Algebra 2 stuff and how we're going to pull this in. We've been talking a lot about doing what? What did I tell you this whole unit was about? Factoring was a way to do what? What about the quadratics? What are we doing with quadratics? Solving. That's exactly what we're doing. We're talking about all these different ways to solve. So far, we have graphed and found the x-intercepts. That solves. We also did what? Factored and solved. We factored, set each piece to 0 and solved. Now I'm going to show you one more way, and this is probably the easiest of all the ways, but it only works in certain situations, okay? Five square roots. When you find yourself in the situation where there is only one x in the problem, okay? X squared, 5x squared, 10x squared, or 2x, 3x, we're going to sad map our way out of it. Have you guys been taught sad map? So how do you know the order that you're supposed to solve an equation in? Backwards PEMDAS, which is sad map. Were you taught backwards PEMDAS? It's not, I was excited for a minute. So what did your teacher tell you? If you have an equation and you have to get x by itself, how do you know what to do first? But how do you know? Nobody ever, like if I had 2x, bless you by the way, minus 3 equals, I don't know, 15. How do you know what to do first? You get x by itself, but how do you know what to do? What would you do first? Add 3. How do you know that you add 3 first? Just cause. Okay, well, what if I told you there's a reason you do what you do? You did the line down the equal sign. But why do you get rid of the 3 first and not the 2 first?
I'm in factor.
What are they teaching y'all in Algebra 1? Oh my goodness. Okay, so when I simplify something, I go PEMDAS, right? We all know that. Parentheses first, exponent, multiplication, division, addition, subtraction. But when I solve, solving is the opposite of simplifying. So I'm going to go in the opposite order. So I'm going to look and I'm going to say, is there any addition or subtraction being done to x that I can get rid of first? Is there? Yes. Because subtracting 3 here, right? So I get rid of that. How do I get rid of that? Adding to both sides. Right? So now 2x equals 18. I've done this. Now is there any multiplication or division being done to x? Yes, so I need to divide by 2. That's exactly right. And now x. That's why you do that. And I know that it's pretty easy. Some students say that they've been taught that you start the furthest away from x and you work your way in. Different teachers teach it, but really, that doesn't always work. This always works. SAD map will always work. So just see one x in your equation, you're going to SAD map your way. The only difference in this and solving and what we're going to be doing is we're going to throw a squared in there. So my next question is how, these are addition, subtraction, opposite operations. They cancel each other out. Yes? Multiplication, division, opposite operations cancel each other out. What then cancels out a squared? In other words, if this equals, I don't know, 18, how would you solve that? How would you get x by itself? What cancels out that exponent? Square root. That's exactly right. This and this cancel each other out. And so that's what I do to both sides to get rid of it. And then I'll go through my simplification process. Does that make sense? All right, let's work one together and let's see how much sense it makes. So we're going to get x by itself using SADMAP, and when we get to an exponent, we're going to use the square root. Notice on SADMAP, parentheses are dead last every time. Keep that in mind. We'll start easy. See how there's only one x in here? There's not, I'm missing the bx term, right? So instead of setting equal to 0 and solving, factoring and solving, I'm just going to SADMAP my way out of here. I'm going to get x by itself. How am I going to do that? Divide by 2. Why are you dividing by 2 before taking the square root? You are exactly right. Because this comes before this. See why it's a little bit important to know why you do what you do now? Because now they're going to start looking like, well, they're both just as close to x, right? It's hard to know what to do. So I'm going to divide by 2. Now I have x squared equals. How do I solve for x? Now I'm on to my exponents. Square root. X equals what? X equals what? There you go. That's important because this quadratic crosses the x-axis at both 4 and -4. So I have to include that plus or minus as I solve because they're both solutions. Now, this is different than this. What's different? That's right. Now this time, I'm still SADMAP, right? But this time, because parentheses are last, I've got to handle the exponent first. So what am I going to do? That cancels the squared out because my parentheses has to be last. So now I have 2x equals the square root of 32. But wait, the square root of 32. Can I simplify that in? That's absolutely right. Good job. The square root of 16 and the square root of 2. What's the square root of 16? So I've got 4 root 2. Now what? Divide by 2. I generally hold off till the end to do my plus or minus and just throw it in front of the problem when I'm done. Now, I know I can't simplify those because this 2 is not under a radical, but what about these two? Yes, neither one of them are under a radical, so I can simplify. What's 4 divided by 2? It's up top, so I have 2 square root 2, and I throw that plus or minus in. Still easy? Yay! If you flip over on the very first page that I gave you, I'll give you a couple reminders. Never divide by a fraction rather than dividing by a fraction. What should you do? if you get yourself in a situation, I'm gonna whoever y'all had for algebra 1, I'm fixing to go beat them up because oh my goodness. If I needed to solve that, what do I do first? But instead of dividing by that fraction, multiply by the reciprocal. Never divide by a fraction. So we're clearly going to move a little bit slower than what I had anticipated. But thank y'all for telling me that you didn't know how to do it this time. Because I had planned on doing both pages today. Well, that's okay. I'll keep y'all on the same page regardless, so y'all will set the pace for both classes. So y'all make sure you tell me. So here, instead of dividing by a half, which I mean you can, it's just, it gets hard, especially if you don't have a calculator. I'm going to multiply by 2 over 1 on both sides. And this cancels, and I'm left with x squared equals 50. And now you can do the square root. Good job. It's 25 and 2, which is 5 root 2 plus or minus in the front. Everybody okay? All right. So your homework tonight is not too terrible. It's we'll do the front and back of this first sheet. Just sit this other sheet to the side. Don't worry about it just yet. We'll pull all that together tomorrow. But for today, let's do, so it's 1 through 9 on one side, 1 through 12 on the other. The 1 through 12 shouldn't take you too terribly long. Neither should the 1 through 9, honestly. The whole thing shouldn't take that long, though. Just quickly, while you're here, look at the first of the radical page. This is the radical is any expression with a square root, cube root, etc. Write in the blank what the radical symbol looks like. What does it look like? That's right. You've already listed the first 20 perfect squares, but let's see. Simplifying radicals. Case 1, perfect squares, take the square root of the number. We talked about that. And case 2, that's where we split it up with the perfect square. Yeah. You should be good. All right, I'll let you get to work on it. You got about 15 minutes left. Well, I guess about 12 minutes left now. If you want to work on that for